Sorry, 1 second. Okay. So before I start and jump into digital fabrication, I just wanted to add this little intro about jewelry making, but more like traditional jewelry making, because I think it's very important for to have like the foundations of how jewelry started, because a lot of machinery that we use now as jewelers is based on those traditional making methods. And they've also been very important for me because that helped me a lot with my formation and the way I also, let's say, do my own working process. So it has built my own way of working and also of thinking related to design. So these are some. I just put a few things also because we have a short time. These are a few of the traditional techniques, but not the only ones. So beadwork, it's actually one of the is the oldest recorded jewelry making technique, because there was a necklace that was found and it's dated from 142,000 years ago. So it's one of the oldest techniques, and it sounds simple, but it was one of the first expressions of making wearables, like jewelry, things that you need to wear. And they were using seashells or organic matters to make them. So and it's a foundation of jewelry making beadwork, as simple as it sounds, but it's quite important. Then there is metalwork that is also dating back a long time ago. And basically metalwork, it's a manipulation of metals, and they can be sheets, they can be wires, and they are manipulated through different processes like let's say welding, sewing, stamping, molding, and you work directly with the metal. And this is also one of the pillars of jewelry making: silversmith, metalsmith, goldsmith. Then there is wax carving, which is one of my favorites as well, and one of the oldest too. So basically, wax carving, it's like sculpting. It's a process that was invented around 6,000 years ago, and it's still being used. So it's not something that has been lost with the time. It's actually one of the main techniques that is used for jewelry making. And these three techniques, they are all handmade, like purely handmade. Of course, there are hand tools, but it's all made by hand. And the interesting thing that we have now for a few years already is that there are equipments that they don't replace those techniques, but they aid or replicate some way of making these processes. And here is where we're going to talk a little bit about digital fabrication and how they kind of emulate these processes. So just going back briefly, metalwork, for example, you are transforming the material. So you have an existing material and you are either removing or reshaping the material. Wax carving, you have a piece of material and you remove material. So you can see that one is by addition and one is by removing material. So in digital fabrication, there are mainly three categories that maybe some of you are already familiar. Basically, these three main categories are computer-aided machinery manufacturing techniques, and they are divided into formative, subtractive, and additive. Formative, like the name says, you create a shape from normally it's from molds. So you make molds, and from the molds then you can pour the material. Subtractive is that you remove material, so it kind of is similar to, let's say, wax carving. You are removing material, whereas adding or modifying. And inside the category of subtractive manufacturing techniques, we have the most common, that is laser cutting. and that for me is one of the machines that I use the most for jewelry making. Water jet, lathe. So these are a few of the most used machines in the world of jewelry making. And then there is the additive one that is 3D printing that some of you maybe already know. And for jewelry making, there's a lot of materials that are used for. So it really depends what's the outcome. So we're gonna see right now. Depends what is the end product that you're going to make. Then you choose which tool is best. These are some examples just to show you what they look like, and also to tell you some that in my experience I've used. So for formative, this photo on the left, it's a machine that basically it's a vacuum. You can place a shape and then you create a mold out of it. And in jewelry, it's not that common, but it is used, for example, for jewelry that is made in resin. You can make these plastic molds. It's like making popsicles. You make these molds and then you can pour the material on it. As I said, it's not super common, but it's used. And I think there is a big, I don't know, field of exploration for vacuum forming and jewelry making. Subtractive, as I mentioned, laser cutting is one of the most common and mostly used and most accessible as well to use for jewelry making or even for other applications. And I am familiar with the CO2 laser. It's just a type of laser cutting machine. It's the one that you would find almost everywhere. And you can cut not infinity of materials, but you can cut a lot. So from wood to acrylic, leather, some plastics, not all of them, metals as well. So in my experience, for me, laser cutting, it's a very fast way to make prototypes, and also the price is quite cheap. But of course, you are having a result that it's a flat product, so you don't have a volume unless it's something that it's press fit or is something that it's assembled together. Then for additive, in my experience and what I use lately, what I use the most is this kind of printer that it's from 3D Systems. It's a company. And basically these printers, they are quite high-end printers. They use wax. It's called castable wax. So the product that is printed, it's then casted. So this wax, it's for a process that is called lost wax. And there's a mold where after the product is 3D printed, this goes into a cylinder where you pour cast. And then this cylinder goes into an oven. And then this oven, because it's it's heat, it will melt down the wax and harden the cast, meaning that the end product that you will get from the oven, it's a negative mold of your piece. And then on this mold, you pour the metal. Can be silver, can be gold, can be platinum, brass, or different alloys. And as I said, this is a machine that I use the most. I don't have it because it's not something that you can have at home, that kind of machine specifically. But I normally work with factories here in China, and it's quite straightforward. I send my files to them, my 3D models, and then they will print them out for me. And after printing them, because this wax is quite brittle, they cannot send it to me. So I don't do the casting myself here, like in-house. I do it directly with their factory. Otherwise, if they send to Shanghai, it might break down and then it's worthless. So this same factory offers the possibility of printing and then casting. And time-wise is pretty fast. So for me, like, let's say I design an earring and a pair of earrings, and in 2-3 days, the model is printed out and already casted. So it's pretty fast. And yeah, the quality so far that I've been working with is pretty good. And it allows you like if there's for example, I'm doing a prototype, but I need to do some changes, so it gives me time to work on going back and forth on the design of the product. So to use this machinery that it's so fantastic, you need to first have a model. So CAD and CAM are like together always, because machinery, computer-aided machinery, as the name says, needs a file that is created from a computer. And here is where we have CAD technologies. And mainly for CAD, we have mainly 2D and 3D. Then inside 2D and 3D, you have so many softwares that create different files, but per se it's 2D and 3D. And after you create this file, you can translate it to the language of the machine you're going to use, and then the machine will execute the functions, right, to make it. The great thing about, and the advantage about using CAD is that it's pretty fast, so you can have a quick, well, relatively fast. You can have a draft of how it's going to look, this final product, and then just do iterations on it, but go back and forth on the design. And I personally, I wrote down a few softwares on the down on the names. It doesn't mean they are the only ones, but it's the ones that I use the most. For example, for 2D, I mostly use Adobe Illustrator. It's a vector software. And from that software, I can create files that a laser cutter can use, just to give you an example. And for 3D printing, I use different softwares, but mainly I've been using Rhinoceros. But I wrote down the second one that is called Matrix Gold, because for jewelry making, there's a lot of softwares out there, like a lot. And there are some that are specifically for jewelry making. And let me just show you. This is the interface of Matrix Gold. Basically, Matrix Gold, it's as I said, it's a software that it's for designers, for jewelry designers. So it already has a inbuilt library with stone settings, stones, sections for rings. So it's already giving you a lot of help when it comes to producing a jewel. And because it's meant for jewelers, it's pretty like, although the process is also quite standardized. So it's a great tool. The only thing is this one is not open source, so it's a little bit pricey, but it is a good software. Then of course you can find open source softwares that you don't need to pay for the usage. And I wrote down a few names that are here, and they are quite nice softwares. So behind this machinery and technologies, well, there should be, or at least I hope, or everyone has some workflow of how they use these equipment. For me, I wanted to explain what is my workflow as a jeweler designer. And actually, I guess for many it's kind of similar, but at least for me, it's not straightforward. It's like it's rather messier, my process. But basically, yeah, it all starts from an idea, from an inspiration. And then after having this inspiration, I get this idea in my head. And then I can start sketching, or yeah, normally I start sketching first. And sometimes I go straight into my computer and I start making the 3D model or the vector drawing. Or sometimes I go into prototyping directly, but I don't intend prototyping as 3D printing. It's more prototyping like with things that I have handy. So it can be paper, wax that I have here. So it's more like a handcrafted prototype. But it's, as I said, it sometimes depends, like also on the time constriction. So sometimes I just jump directly into making the 3D model. Sometimes I do have the time of sketching and then making a prototype into the model. But generally speaking, I always have a 3D or a 2D model of my designs. And then I choose what equipment I'm going to use. And like I said before, I mainly use laser cutting and 3D printing for my work. So once my design is done in the computer, I send it to the factories. Then the factories will print and cast for me if it's a 3D model. And after the product is done, the work is not done. Like I receive the samples, and then there is a post-processing part. So it's cleaning the samples. For metals, there is like filing, polishing, cleaning. So it's not like it just you print and then it's done your product. There's a whole lot of processes involved. Also, if it's a one-of-a-kind piece or a small amount, I can just 3D print. But if it's like a mass production, there might be involved a part where I need to make a mold, and then you need to make the mold, then you need to make the injection on the molds. So it really depends on what exactly you are doing and what are the amounts of the product that you're making. Anyway, so this is kind of how it looks for me. And after I have the product finished, clean, ready to use, I like to try them out. I prefer, like, I really like to feel how they feel like by touching them, right? Like how they feel when you wear them, if they are uncomfortable, if they are too heavy, or if they are sharp. So when there is time, which most of the cases is quite limited, but I try to like try things first before I can launch a product. So I feel more comfortable like selling something that I already tried. Um, so yeah, after the testing, then I release my products online, and most of the time I go back to the design again. Like, oh, I realize there's something I would like to change or something I would like to add. So I think it's more a cyclical process rather than linear. Um, so yeah, I just found this illustration to give you an idea, but kind of like sometimes I feel like that, like I kind of have the ideas in my head and how I want to do it, but then it's just like things don't really like connect well. So just the workflow is never perfect and it doesn't work always well. But yeah, just I wanted to add that. And well, we still have a few minutes. Um, so I just want to show you a few stuff that I've done and what kind of machinery I use to make them. This is a this is a series of rings that I made using laser cutting, CO2 machine, and also the display that you see on the left. I also designed it and I also like assembled it and did all the gluing because some parts I actually glue them. So just to give you an idea, I try to kind of mix equipment. This is also subtractive, so laser cutting. On the left, you can see some pins. They are made in stainless steel, so it's all laser cutting. I did first like the samples in acrylic, like in a lab that was close to me, just to see like to make the prototypes. And then when I was sure about those sizes and designs, then I sent them to a factory to make them because they use a little bit with higher voltage laser, so it's a bit different. And on the right there is that's a pin, and the structure of the pin it's all done by laser cut, and I'll talk about that one later. This is a collection that I work on for a Chinese company. And here we used most of the time, well, all the time, we were using CNC, 5-axis CNC machines to cut jade. That's a kind of stone, if you're not familiar with. And I was quite impressed when the first time I saw it because the machines are quite big, but actually the part that is cutting the stone is just a tiny little thing. And then you have the water jets like releasing water because otherwise the stones would break down. So there has to be has to be water or a fluid, so otherwise it will just break down with the drill bit. So these ones I did the 3D model, and then they go directly into the machine, and we cut the jade. And actually, the one on the right, it's a combination of laser cutting and 5-axis CNC. This is yes, quite simple. It's just 3D printing. So I make the 3D model, and then I did the wax. I printed the model in wax, and then we did the casting in silver, and then I did all the cleaning by hand. So it's just to show you some examples. Same thing here. So you go from 3D model to a final object printed and casted, and all the post processing is done by hand. This is subtractive and additive. So I used laser cutting and 3D printing. So actually, there is I'm gonna see if you can see. There is like a metal bar here. This is an insert that I did with 3D printing. So I designed everything in a software. Everything was like press fit, and then I cut in laser the parts that are in acrylic, and then the bar I did the printing in wax, and then the casting. The only thing is it's quite difficult because you need to. It's a lot of work because you need to do a lot of tests and see if they fit properly. Because sometimes the machine, I don't know, when you're depending what machine you're using, when you cut the curve, like the space when you cut, it might be bigger or smaller. So sometimes I would end up with the parts not being able to assemble. So it's just this takes a little bit of time to make. But I wanted to combine acrylic and metal and laser cutting and 3D printing. So here are some examples. These ones were for an exhibition here in Shanghai. Then I also tried to integrate some simple electronic circuits. So this is again, it was like the previous image. It's laser cutting, and I built inside a very simple electronic circuit with LEDs and a 3-volt battery. This is one of my latest products, and here I used the part that you see on top. It's silver, it's metal. That part I 3D printed, and then I did all, as I explained before, I did the cleaning, and also I did a gold plating to protect from tarnishing the silver. The bottom part, it's acrylic that I bend by hand, and I add the color also by hand. I do like a hand dyeing. So yeah, I kind of like the idea of playing a little bit with tools and mixing them. Sometimes the outcome can be nice. Sometimes it's not what you expected. Sometimes you get to learn even more things that you were not thinking about. So yeah, that's just to give you a bit of an insight to my work and the field of jewelry making. And I think the nice thing about jewelry making is that it can be quite playful. So I just want to leave you with some examples that I think that could be also nice to think about, or just take them, I don't know, as inspiration for other things. I think mixing, for example, this is a 3D printer for food, and I always found very appealing the idea of jewelry that can be ephemeral, that doesn't last like forever. So what about, I don't know, jewelry that there are already projects that I've seen online, but what about jewelry that you can just eat, like, you know, you're wearing it for a short time, or is this something that is just to be part of I don't know, you go to a dinner and it's part of the whole say performance that you're eating your plate, in that it's in your body. So these kind of things, like, I think jewelry is very adaptable in that sense. And then some machines that may look boring, or not boring, but maybe like already old, like laser cutting is actually not that new. But if you think about it, there's so many other ways you can use old equipment in new ways. These are very nice ideas that are actually quite simple. So it's like creating a flexibility in materials just by doing a repetition of patterns. And in jewelry, that can be applied. Yeah, so just to give you some ideas here. Or just, what about using like just simple concepts, but utilizing new equipment? So how can you, like from a simple idea, how can you use, for example, 3D printing or laser cutting to make reality this simple idea? This is on the right, it's a very nice idea from the 70s. This designer made these pendants. He was asked to make a collection of the zodiac symbols, which is very common. And he wanted to do something not that usual. So he thought about playing with the light and shadows. And he created these beautiful and very simple medals with the holes that are exactly where the constellations of that sign, are. So imagine like taking this kind of approach of simple things, but using new technologies. Like where can you go? Where can you get to? So it's just like leaving you with some ideas that maybe you can share or take with yourself. So yeah, I think that was a little bit it. This is my contact. So I'm based in Shanghai. I have my official account on WeChat where I post about my work. I also have an Instagram and my email is there. So if you want to take a screenshot, you can take a screenshot of the contacts. And yeah, I would like to just, if anyone wants to ask anything or you want to add anything into the conversation, just let's do it now. If not, then we can just wrap up. So thank you.
I think that there were questions in the chat from Kai.
Okay, I see them.
I was just wondering. Well, thank you for the presentation. It was insightful. I was just wondering the one of your work that is made by metal, stainless metal, and I saw like the black mark on it. Yeah, that one on the left. Is
Yeah.
that yeah, is that a laser marking? You used CO2 laser to mark it?
Yeah, this is stainless steel, and we did both engraving and cutting. So this black, it's just when the is engraving part of the metal. Yeah.
So you just like engraved like directly on to the metal, I mean the stainless steel using CO2 laser.
Yep. Yep.
Oh.
It's I don't have the machine because they are quite big, those ones. I work with a factory. So I just send my files to the factory and they do it for me. But yeah, it's cutting and engraving.
Okay, thank you.
Mm-hmm. Yeah, I mean here in because I think the majority are here based in China, but the good thing here is that you get a very easy access to production in China, and sometimes it depends what you're doing, but prices can be affordable. Whereas if you're doing it in, I don't know, if I were doing it in my hometown, it would take a long time, and I don't think there's all this equipment so accessible. Here you can just connect online, talk with a factory, send your files, they do it, they send it back, you check. So I think it's quite smooth for producing here, small quantities.
Is that a reason why you moved to China? I mean, all those
not really. I moved here about 8 years ago, and I moved here because I was visiting, and I was just very amazed by the country itself, and I was like, maybe I can give it a try and find work here. So then in the end, I found a job and I stay here. But I didn't come at first place because of the let's say accessibility for production.
I see. So like how did you like start the career as a jewelry artist?
I started jewelry design. I did my major in jewelry design in Italy. I studied in Rome. Yeah, so it's a major of specialized in jewelry making.
Okay, thank you.
Yeah, well, I don't know if anybody would like to add anything or just say anything else. Just let me know. Yeah, if you want to find me, I'm gonna share my details again soon before I close the conversation. And thank you everyone for joining, and I hope you take something and it's useful. And thank you guys for organizing it at Fab Labo, for taking the time of making this space. Thank you. Okay.
More question, Pamela.
Hello.
Where can we access? Hi, hola. Where can we access laser cut and all these machineries in Shanghai? Is Fab Lab open for public?
If you want to use it yourself, I think there is still Xinjiajian. It's a makerspace in Shanghai. I'm not quite sure what is the last update because they were closing and then they were reopening. But I know there's one makerspace that is accessible to the public, and it's Xinjiajian. But again, I'm not sure. I didn't follow them again. I normally now work with factories directly because I also I don't have much time to go myself, so I just do it with the factories. Otherwise, Fab Labo, we would need to ask. We can ask Saverio. I don't know if he's online, but Fab Labo, as far as I know, they are. It's a private lab, so it's not open to the public. But you can ask. You can ask Saverio. He's here. Laila was asking if she could have like where could she have access to this kind of machinery in Shanghai. And I think Xinjiajian is the only one that is standing. Do you know, Saverio?
Yeah, definitely you can contact me or come take a look.
Okay, it's open to public
Thank you.
for usage.
On a case-to-case basis, yes.
Okay. Okay, thank you. Okay, guys, so I think that's it. Thank you so much.
Thank you, Pamela,
Thank you,
and
guys.
everyone. If you want, we are going to have the closing party in 20 minutes. You can go back to the main room, and we are going to have hotpot as well.
Okay. Nice. Okay,
Bye
guys.
bye.
Bye. Bye bye. Thank you.
Bye bye.
Bye.